Hello everyone, my name is Artur Pinto and I'm a researcher at LEPABE FEUP. I found out about this call through a postdoctoral researcher from our group, Raquel Almeida, which proposed me to submit an abstract with our work to UT Austin, Portugal conference. I've been in the United States, doing my PhD work in the final part, and I was interested in establishing collaborations across the ocean. So I accepted that proposal, and there was the possibility of creating a profile for cooperation in the website of UT Austin, Portugal. So I created a profile, and then I have a Zoom talk with Gina and Incorvia. And we found out that we have interests in common exploring 2D nanomaterials for the different applications, most focused on biomedical ones. So that's where everything started. That's how I had contact with the UT Austin Portugal program. I didn't have the proposal in mind. We have been working with 2D nanomaterials in the past, especially graphene-based materials. That's where I started my research at LEPABE with Professor Fernando Magalhães. That was 12 years ago. At the time, graphene, which is a monolayer of carbon atoms, and it's the elemental component of graphite that you can find in your pencils, has been awarded the Nobel Prize in Physics. So the researchers which isolated it for the first time were awarded this prize because of its relevance and all of its potential applications. So it was a very hot topic at the time, and we realized that on the biomedical field there wasn't much done. So we didn't know how it interacted with our body or which applications it could have on the medical field. Therefore, we have written the first review on the field, and I focused my PhD work on studying graphene and graphene composites for biomedical applications and trying to understand how we can modify graphene-based materials to make them more biocompatible and more interesting for this type of applications. The main goal of 2D therapy is to treat lung cancer. Lung cancer is the main cause of death by cancer in the United States and in Portugal. More than 20% of the patients can't do surgery to treat lung cancer because they have other associated disease. And also the current offered treatments such as chemotherapy, immunotherapy are not as effective as desired, and the cure rates on lung cancer are below 20%. And alternative treatments to the ones I mentioned before are, for example, phototherapy. In phototherapy, using light in the near infrared, we radiate nanoparticles which are so small that you need to magnify them 100,000 times with a modern microscope so that you can see them. These particles, they absorb the light and they will increase temperature and destroy the cancer cells. But currently, what is done is to kill these cells using lasers that destroy both cancer cells but also healthy tissues. So in our project, what we target is using new LED systems that we developed to control this heating so that we can selectively kill the cancer cells but leaving the normal tissues intact, minimizing the side effects of the treatment. Also, we want to combine these new 2D nanomaterials that have been developed in the United States at Gina and Incorvia lab, combining them with drugs, immunotherapy drugs, and we want to evaluate the impact of these materials by themselves, combined with drugs, included in pharmaceutical formulations, in our immune system, how they trigger our body to react and destroy the cancer. And we want to evaluate the effect of all these things combined to find a synergistic treatment. In our team, currently, we have 3 PhD students which are involved in this project and 5 Master in Science students which are also doing their thesis within the research lines predicted in this project. So these projects are very important for the training of the students, And the students are also very important to contribute to the outcomes of the project, and also for getting preliminary results for future projects that we might have in mind.